So as a continuation of my lecture series in control systems, we are discussing about the frequency response analysis. In this unit, we will have main important two topics like Bode plot and polar plot. So generally Bode plot is nothing but there will be a procedure for plotting, and we will have a separate waveform for magnitude plot and phase plot. So why we have to, what is the need for Bode plot is in real world problem, control system designers, filter designers and power system engineers face a problem for calculations and to analyze the system stability. So if we do not concentrate in this, we will be having an unstable system with poor performance and equipment failure also happens. So this affects the professionals' inability to quickly access system stability and performance across frequency ranges. So in the right side of the graph, we can see two plots like gain plot and the phase plot, which is magnitude plot and the phase plot. So the in Bode plot, we have two margins. One is gain margin, another one is the phase margin. So gain margin is nothing but 0 with a gain dB, whereas phase margin is nothing but 180 degrees. So here also we have some time domain limitations and the technology gaps, and this is about no direct frequency insight, so difficulties to visualize the frequency behavior, and computational intensive for higher order systems. The technological gaps like complex calculations, because calculations plays a major role. So when it is becoming complex, then the exact stability of the system may not be able to monitor. So no straightforward stability margin assessment. So here we will have another gain crossover frequency and phase crossover frequency. So the gain crossover frequency is calculated like from the 0 dB, we have to touch the gain margin and we have to come to the frequency line. So if there is 5 frequency value, then that gain crossover frequency will be 5. Whereas a phase crossover frequency, we will have a phase plot and we will have 180 degrees. So from 180 degrees, we have to touch the phase line and we have to monitor the frequency line. So that frequency is called as phase crossover frequency. So coming to the understanding of Bode plot, it is the graphical representation of frequency response with two plots like magnitude plot and phase plot. So magnitude plot value will be, formula will be 20 log. So magnitude plot will be 20 log of g of j omega, whereas phase plot will be determined by angle of g of j omega. So this is asymptotic approximation using the straight line. So coming to the plotting procedure, first we have to, we will have a transfer function. So from that transfer function g of s, we will identify the corner frequency. So after identifying the corner frequency values, we will first mark the magnitude plot, and again we have to go with the phase plot. So in the magnitude plot, we have to identify the terms first. So what is the first term, second term, and for that individual term, we will have a corner frequency and we will have a slope. So if we have s value in the numerator, we will have a slope of 20, whereas s in the denominator, we will have a slope of minus 20. Whereas when we go with s square in the numerator, it will be plus 40, and s square in the denominator, we will have minus 40 dB. So this using this value, we will first fill the table of magnitude plot, and then we will go to calculate the gain values at omega is equal to corner frequency 1, 2 and higher frequency and lower frequency. So after calculating this, we have to go with the plotting in the semi-log sheet. So again, then next we have to proceed with the phase plot. So for phase plot, if s in numerator, we have to go with 90 degrees, and if s in denominator, then we have to go with minus 90. Then if s in numerator, we have to go s square in numerator, we have to go with plus 180, and if it is in denominator, we have to go with minus 180. So this will be the procedure for Bode plots. So coming to the practical applications, mainly with stability analysis, motor control, power systems and filter design. So in the right side picture, we have a clear picture for the Bode plot and the polar plot. So let us summarize that in Bode plot analysis, we clearly dealt with the definition and plotting procedure. So first one is to convert to standard form and identify the corner frequencies and calculate the gain crossover frequencies and corner frequency, then determine the slope and create a table. Similar way for phase. Then after that, we have to mark the gain margin, phase margin, gain crossover and phase crossover frequencies in the semi-log sheet. Thank you. Let us meet in the next video.